So, yesterday we have studied about the three types of expansion. Today we'll study about the activity based on that. Okay, so just I will read through, it is very easy to understand. Linear expansion means lengthwise expansion. Okay, and it happens in solid when it is heated. Suppose here in this activity 1, we'll see aim is to understand the linear expansion of materials, that is solid. You have taken a thin copper wire, a candle, and a meter scale. Okay, thin copper wire is the wire which we are going to heat with the help of a candle, and we are taking a meter scale to measure the length and the change in the length. Okay, so first we'll measure the length of the copper wire. We'll take a copper wire and we'll measure the length. Say the copper wire's length is 5 centimeter. Okay, then after that we'll keep the copper wire above the flame of candle. So we'll take a candle, and over that we'll take a light. First we'll take a lighted candle. Over that we'll keep the copper wire, and we'll heat it. Okay. After few minutes, we will again measure the length of the copper wire. So that time we will see that first it was 5 centimeter, but later there is a small increase in the length of the. Say it is 5.5 centimeter or 5.2 centimeter now. After heating the copper wire, let the copper wire's length be 5.2 centimeter. So this 0.2 centimeter increase, right? Increase in the length shows the linear expansion of the material of the copper wire. So from there we can understand that the length of the copper wire after heating is increased. So the conclusion is linear expansion occurs when a material is heated. Clear? So linear expansion occurs when a material is heated. What we have taken? We have taken a copper wire, thin copper wire. We have taken a candle to heat it, and then we have taken a meter scale to to measure it. Measure the length. First let it be suppose 5 centimeter, and then later when after you heating the copper wire with the candle flame for some time, when we have measured, let it become 5.2 centimeter. So what is the increase in length? 0.2 centimeter. Understood? So that increase in length shows that there is a linear expansion of the copper wire on heating. Yes, so that means whenever a material is heated, a solid material is heated, there is a linear expansion, lengthwise expansion. Clear? Next is our activity 2, where we are going to understand the superficial expansion of materials, that is solid. For that we are taking a Bunsen burner, we are taking a piece of paper, pair of tongues, colored pens, and thin metal sheet. So what we are going to do is we are going to take a thin metal sheet first, and then we have a piece of paper now. Over that we are going to draw the outline of the thin metal sheet. Got it? First point is we are going to take the metal sheet, draw the outline with the colored pens. You are going to draw the outline of the metal sheet on the piece of paper. Okay. Next, with the help of a pair of tongues, we are going to burn the Bunsen. We are going to heat the thin metal sheet on the Bunsen burner. Okay, and then after heating it for some time, we will replace again we'll place the metal sheet on the paper and mark the outline, okay, with some other color. So first if it was red color, later you'll do it with green color, and see that there is some increase in the area. First if it was this much, later it become little increase in the area. So from that we can understand that there is an increase in the area of the material when you heated it with the help of Bunsen burner. Okay, check both the outlines to verify the size of the metal sheet. So it was the same metal sheet. First you drew the outline without heating it, and next you drew the outline after heating it. So there is a change in the size. There is a change. So that change in the size of the metal sheet on heating shows the superficial expansion of material. Okay, so the observation is the outline of the metal sheet after heating is slightly increased. Okay, expansion increased. The conclusion is superficial expansion occurs when a material is heated. So from this we can understand that when a material is heated, superficial expansion occurs. Okay. I hope you understood. First you took the metal sheet and drew the outline on the paper. Okay. Then you took the metal sheet, okay, and you heated it using a Bunsen flame, Bunsen burner. Okay. So after heating it, how did you heat it? With the help of tongues. There is something called as tongues that will help you to hold the metal sheet. After that, when you again keep the same thing over this, okay, when you draw it on the paper, you will see with another color, you will see that there is a slight increase in the size of the metal sheet. So this increase in the size shows the superficial expansion. Got it? Superficial expansion. This shows what is superficial expansion? That is the tendency of a material to expand in its area when heated. So there is the area increased when you heated it. Got it? This is a superficial expansion. Our next topic is thermal expansion of solids. Solids expand upon heating and contract upon cooling. Solids are held together by a strong intermolecular force. You know that. Every solid is a matter, and matter has molecules, and there is a strong intermolecular force in solid. Okay. So expansion in solid is not much and is sometimes not very prominent. Sometimes expansion occurs, but we are not able to see that much changes. Okay. There is an expansion, but the change cannot be seen so vividly. So let us do a simple activity to understand the expansion of solids upon heating. Okay. So our activity 3 is to understand the expansion of solids. To verify the expansion of solids on heating, materials required are metal ball, metal ring, and candle. Okay, so we are taking a candle, we are taking a metal ball and a metal ring. So first what we'll do, we will pass the metal ball through the ring, showing that the metal ball is able to pass through the ring because it is of both the ring and the metal ball, both are of same diameter. Got it? That's why it is able to pass through. This thing shows that it is able to pass through. Okay. Next, we are going to heat the metal ball, and after heating the metal ball, we are going to try to pass it through the same ring, but we will see that it is not passing through. What happened? Why did it not pass through? Though it was passing through before heating. That means expansion happened. It increased in its size. Because it increased in its size, it is not able to pass through. Got it? So I'll just read the procedure once again for your understanding. First, make sure that the metal ball can just pass through the ring with a struggle. Now heat the metal ball for a while and try passing the ball through the ring. Allow the ball to cool down and try to pass it again through the ring. So after cooling, if you pass it, again it will pass through. That's what it shows, that metals will expand on heating and contract on cooling. So if you let it cool, after heating this happened, after cooling again this will happen. Okay. So when a ball is heated, it does not pass through the ring. When a ball is cooled down, it passes through the ring. You got it? So after this step, you have to cool down the metal ball and then try to pass it through again. And you will see that you will be able to pass it through. That means it again contracted. It again came back to its own shape, right? So it again contracts and it is able to pass through. Solids expand upon heating and contract upon cooling. So this is your activity 3. The rate of expansion differs from material to material. For example, expansion of brass will be more than that of iron of any temperature, at any temperature. Some materials start expanding at low temperature while some expand only at high temperature. So all materials are not same. Yes, some are copper, tin, all have different, heat capacity. That means ability to absorb heat and melt, or ability to absorb heat and expand. Every material is different. So it depends on the different, the expansion rate depends on the material. And some expands more, some expands less. So some materials start expanding even at low temperature. Means like if you give enough heat, in that little heat itself it will start expanding. And some materials you have to heat it a lot, like iron and all, you have to heat a lot to expand it, to see that really it is expanding. Clearly we have to heat a lot. So some expand only at high temperature and some expand at low temperature. Okay, you can try this in the kitchen. Application of thermal expansion in solids. Okay, how do we apply this in our day-to-day life? We'll see. Thermal expansion in kitchens. In a kitchen, it is sometimes seen that the lids of bottles get very tight. Yes, sometimes you are not able to open the lid of the bottle and it becomes very difficult to open. To open the bottle, we run hot water over the lid. Okay, so what happens when you run hot water over the lid? Because of the hot water, the heat of the water will expand the lid of the size of the lid. Okay, so when the size of the lid expands, okay, now bottle is different material. Bottle will be maybe made up of glass, and this is some metal. So the glass will not expand in the same rate as the metal. Metal will expand faster. So what will happen to the metal? Metal will expand and it will become loose. So you are able to open the lid. Okay, so to open the bottle, we run hot water over the lid, which enables it to expand. It means enables the lid to expand, and hence it becomes easy for us to remove the lid. Clear? Sometimes we face the challenge of inserting the rubber tube in a gas stove. Yes, many times we face that. So what do? We heat the edge of the tube a little so that it expands. So when we heat the edge of the rubber tube that is connected to your gas, okay, stove, so that it expands and it becomes easy for us to insert the tube. After you insert the tube, okay, it will contract. So when it contracts, it will get tightened. But when it expands, you're able to, fix the rubber tube in the gas stove easily. Okay, because it is of small size, it is not able to go inside. But when it is heated, it is able to go inside properly. Why? Because of the expansion in the rubber tube. Got it? So we usually heat the edge of the tube a little so that it expands and it becomes easy for us to insert a tube. Okay, next point is power lines and telephone lines. Power lines and telephone lines are usually connected between the poles in a way that they hang a bit loose. So they are not tightly kept. You can see these things in fields. They are not tight. They hang a bit. Why they are kept like that? This is to prevent the wires from snapping as they contract during winter and expand during summer. So these wires, they will expand on summer and contract during the winter because of the cold weather. They will they will contract, and because of the heat of the summer, they will expand. So this expansion and contraction may cause snapping of the wire. That's why, to prevent that, they are keeping it a bit loose. Okay, snapping means getting torn off. Are you understanding? Okay. Our next point is expansion joints on bridges. Most of the large bridges have expansion joints. Okay. In the absence of expansion joints, the bridge will have no space to expand during the day when it is hot. So what happens is, bridges are kept, two bridges, or there are, you will see if you go to big cities, you will see that the bridges will have some expansion joints. Okay, there will be some gaps. Suppose this is a bridge. When you see that the road here and the road here, in between there will be a gap. This gap is called as expansion gap. That is, when there is summer, it will expand. So when it expands, it needs some space to expand. So this gap will provide the space to expand during summers. Okay, so it is made in such a way that it is able to expand, and on cooling also, when it contracts, there is no problem. But if the space is not given, then what will happen? It is going to, the cracks might come. Okay, so what happens is, they keep a space to to expand during the day when it is hot, or when and it cools down during the night. So the expansion joints are like teeth of the two combs joined together. During the day, the bridge expands and the teeth of the expansion joints move towards each other. And during the night, the bridge cools and the teeth move away from each other. This acts as an inbuilt safety mechanism for the bridges. Are you understanding? Okay, so if the bridges, suppose this is a bridge and this is another bridge. Okay, they are like teeth of the two combs. So what happens is when during the daytime there is these gaps are kept. So during the daytime they will expand. Okay, and during the nighttime they will contract. So there is still a connection. Okay, there is an expansion because this road is expanding that side, this road is expanding this side, so there is an expansion. So this tooth like like the comb tooth of the two combs, they are joined together during the daytime and they will move towards each other, and then when it cools down during the night time, the teeth will move away from each other. So this is an inbuilt safety mechanism for the bridges. Clear? Next is our railway tracks. Railway tracks are laid in such a way that there is a gap between the two track segments. You will see that there is a gap between two track segments. Okay, these are the tracks and there is a gap. This is to ensure that they do not bend while expanding during the day. This gap is kept so that they will not bend. They will expand for sure, but while expanding they should not bend. If there will be no gap, then what will happen? They are not able to expand. So if they are expanding, there might be a bend, like this bend or like this bend. Okay, but because they have this gap, they are able to expand. And if they are cool down, they'll cool down like this, contract, again expand and contract. So this gap is there so that they will not bend while expanding during the day. Okay, so these are the 4 applications of thermal expansion in solids.